In this video, we will work through several examples of solving equations that involve fractions. And in our last example, we will write and solve an equation that involves a fraction. So please take notes and go through the examples with me to help you to feel better about fractions. So in this first example, we have a one-step equation in which we are multiplying 1/3 by m and it's equal to 6. So we're trying to solve for m, or we're trying to get m by itself. Now, we know that the inverse operation of multiplication is division, and right now we have a fraction that's being multiplied by m. So if I am trying to find the inverse of multiplying by 1/3, I know that it's going to be dividing by 1/3. And I also know that division is the same thing as multiplication by the reciprocal. So if I'm going to divide both sides by 1/3, that's the same thing as multiplying by 3, or 3 over 1. So that's the operation that I'm going to do to solve this equation. If I multiply the left side by 3, it becomes 1m. And if I multiply the right side by 3, I get 6 times 3, which is m equals 18. And of course I need to check my work. So now I'm going to plug it back into the equation, 18 in the place of m. So 1/3 times 18 over 1 will hopefully equal 6. And it does, because when I multiply the numerators, 1 times 18 is 18, 3 times 1 is 3, and 18 divided by 3 is 6. So this one does check. 6 equals 6. All right, let's look at the next example, which is also a one-step equation. In this equation, we have 2/5 being multiplied by c. So once again, I'm going to use the inverse operation of multiplication, which is division. So I need to divide both sides of the equation by 2/5. Dividing by 2/5 is the same as multiplying by the reciprocal, which is 5/2. So I'm going to multiply both sides of the equation by 5/2. If I multiply the left side by 5/2, it's just left as 1c. And now if I do the right side, I'm going to do 10, and I'm going to write it as 10 over 1 times 5 over 2. So I could just go ahead and multiply the numerators and multiply the denominators. I can also do some reducing before. I can divide both the 10 and the 2 by 2. 2 goes into 2 one time. 2 goes into 10 5 times. So now all I have to do is multiply 5 over 1 times 5 over 1, which is 25 over 1, or 25. So c equals 25. And of course I need to check my work. So when I plug it back into the original equation, 2/5 times 25 over 1 equals 10. So I can, before I multiply these two fractions on the left side, I can reduce. I can divide these two numbers that are diagonal from each other. I can divide both the 25 and the 5 by 5. 5 will go into 5 one time. 5 will go into 25 5 times. So now I'm left with 2 over 1 times 5 over 1, which is just 10. So 10 equals 10, and it checks. All right, looking at example 3. This is a two-step equation, and I need to solve for x, and I'm going to use inverse operations and reverse order of operations. So my first step would actually be to subtract 1/3 from both sides. If I subtract 1/3 from the left side, it becomes 0, and I just have that 3x by itself. And if I subtract 1/3 from 3/4, well, before I can do that, I need to find a common denominator, because I can't subtract fractions with two different denominators. So I'm just rewriting this out to the side here. I need to find a number that both 3 and 4 will go into. They will both go into 12. So I'm going to pick 12 as my least common denominator. 4 will go into 12 3 times. So that means I need to multiply the numerator by 3 as well. That is 9/12. 3 will go into 12 4 times. So now I'm going to multiply the numerator by 4. So my numerator is 4. Now I can subtract the two fractions because they have the same denominator. 9/12 minus 4/12, which is basically just 9 minus 4, which is 5, and I keep the same denominator. All right, so now I'm at a one-step equation, and I need to isolate the x, which means I need to divide both sides by 3. Now, remember, dividing is the same as multiplying by the reciprocal. So I can divide by 3, or I could also look at it as multiplying by the reciprocal of 3, which is multiplying by 1/3. So 3 divided by 3 is 1x. And again, I'm going to do it as a multiplication problem instead of division. So I'm multiplying it by 1/3. 5 times 1 is 5. 12 times 3 is 36. So I get the fraction x equals 5/36. It's kind of an ugly answer, so let's check it. So let's plug it back into our original equation. 3 times 5/36. I'm going to go ahead and write it as 3/1 plus 1/3 will hopefully equal 3/4. When I multiply 3/1 times 5/36, I'm going to go ahead and reduce the 3 and the 36 by dividing them both by 3. So 3 divided by 3 is 1. 36 divided by 3 is 12. Then I just get 1 times 5, which is 5, and 1 times 12, which is 12. So now I have 5/12 plus 1/3 will hopefully equal 3/4. Before I add the 5/12 and the 1/3, I need a common denominator. I'm going to go ahead and keep that denominator of 12, and I'm going to rewrite the 1/3 as a fraction out of 12. Since 3 goes into 12 4 times, I'm going to multiply 4 times 1. So I get 5/12 plus 4/12, which is 9/12. If I reduce 9/12, I divide them both by 3, I get 3/4, and they are equal. 3/4 equals 3/4. Okay, looking at example 4. Oh good, this one's a little easier. This is a one-step equation. I'm trying to isolate the w, and therefore I need to add 3/2 to both sides. Good news, they already have the same denominator, so I don't have to do any rewriting of denominators. 3/2, negative 3/2 plus 3/2 is 0, and then 1/2 plus 3/2 is 4/2. So I get w equals 4/2. 4/2 can be reduced, or simplified, I guess I should say, because it's an improper fraction. 4 divided by 2, which is 2. So w should equal 2. Let's plug it back in to make sure. So when I plug it back in, I'm actually going to plug it back in as an improper fraction. 4/2, sorry, that's really messy, minus 3/2 is 1/2. 4/2 minus 3/2 is 1/2. So it does check. Okay, the last example is a word problem. So we have to both write and solve the equation. Eva just got her first job after college and would like to spend no more than 1/4 of her monthly income, of her income, her total income, on her monthly rent on her new downtown apartment. She plans to spend no more than $2,000 each month on rent. What is her monthly income? So we're trying to figure out our monthly income. So I'm going to go ahead and just say, I'm going to say D. I'm going to pick the variable D, and D is going to stand for her monthly income. That's basically the total amount of money she makes per month. Okay, so now we know what our variable is and what we're trying to find out. What else do we know? Well, we know exactly how much she wants to spend on her rent. We know that she's spending exactly 1/4 of her total monthly income. So that's kind of a clue right there that I'm going to multiply 1/4 times her total income. So 1/4 times D, or 1/4 D, is going to equal exactly 2,000. So 1/4 of her total income is equal to 2,000. Now we're going to solve this equation to figure out what is her monthly income. You can probably do this in your head, but let's go ahead and show the steps. So if I need to do the inverse of multiplying by 1/4, I'm going to divide by 1/4. Dividing by 1/4 is the same thing as multiplying by 4 over 1. So now I'm going to do times 4 over 1, which gives me 1D, and 2,000 times 4 over 1 is 8,000. So her total monthly income is $8,000. She must not be a teacher. Ha ha. Okay, so now let's check our work. 1/4 times 8,000 equals 2,000. So 1 times 8,000 is 8,000. And then I guess that's technically over 1. 4 times 1 is 4. 8,000 divided by 4 is 2,000. So it does check. So I hope that this video helped you become a little bit more confident with equations that involve fractions.